So in this series of videos, we're going to learn pretty much the most important theorem for the second half of the course, which is dealing with area under curves. Before we get there, we'll talk about the mean value theorem for integrals. We already talked about it for derivatives. So you may or may not recall the mean value theorem we talked about earlier in the year. It said if we have this continuous function, this function, and we take the secant line from, let's say, A to B. So the secant line is going to have this slope that connects A to B. Then there's some point C where the tangent line is parallel to that secant line. So here it'd be about there. That tangent line at that point C is parallel to that secant line. So that's the mean value theorem for derivatives. For integrals, it's similar, except for instead of having slopes of secant lines and stuff, we have the average value. So this was our formula for the average value of a function. It was the kind of area, the integral of that function from A to B, and then just the distance from A to B. So that's the average value on the right. It basically says there's some place where our function value is exactly the average value. So we have this function that goes kind of up and down. When we average it out, we're going to get some thing in the middle. But there's at least one point where our function exactly hits the average value. So that is the mean value theorem for integrals. A little bit different than the mean value theorem for derivatives, but it still tells us like there's something in the middle that hits this average amount.